Hello everyone, today we will start 9.5 Graphing other trigonometry functions. In the last video we have done the graphing of sin x function and cosine. There are other functions as well like tangent, cotangent, secant, cosecant. So we will try to draw their graphs also. Okay, let's start it. I draw some values here, some x values, and let's see what's the values for the tan corresponding. Tan at negative pi by 2, it is undefined. At negative pi by 4, it's negative 1. At 0, it's 0. At pi by 4, it's positive 1. And at pi by 2, it's again undefined. Now, at cotangent. Cotangent at negative pi by 2, it's 0. At negative pi by 4, it's negative 1. At 0, it is undefined. At pi by 4 it is 1 and at pi by 2 it is 0. So 0 is there, pi by 4, pi by 2, negative pi by 4 and negative pi by 2. Let's mark the points which are defined only. The value at negative pi by 4 is negative 1. At pi by 4 it's positive 1 and at 0 it's 0. Pi by 2 is undefined, so I draw asymptote, a vertical asymptote here. Now draw a curve that connects them. It's like this. Done. That's it. This is the graph of a tangent function. It's a y equals to tan x. Now for the cotangent, 0, pi by 4, pi by 2, negative pi by 4, negative pi by 4. Where it is undefined? It is undefined at 0. So at 0 it is undefined. And the other values at pi by 4 it's positive 1, here it's 0, it's negative 1 and it is 0. Now try to connect. If you try to connect, it will be like this. Okay, it will be like this again. Here. Let's talk about the characteristics of this function. Characteristics of tan x. Like sin x and cosec, there is a no amplitude because there is a no maximum value. It goes to infinity from highest and negative infinity to the lowest value. So no amplitude. Tan x has a period of pi, not a 2 pi. You can see it starts at a negative pi by 2 and at a pi by 2. After, if you try to draw again, the curve will be like this. Okay, the curve will be like this. So one complete curve is defined from minus pi by 2 to positive pi by 2. So length is a pi. Amplitude is no amplitude. Period is pi. Okay. What about the domain? Domain means what are the x values you can substitute. In the case of tan x, you cannot put any value which is a multiple, which is an odd multiple of pi by 2. Odd multiple of pi by 2 are not allowed. So all reals, but x cannot be odd multiples of pi by 2. Now look at the cotangent graph. In a cotangent, you can start where it's 0 at negative pi by 2, again at a 0 at pi by 2. So here the period is again pi, or you can also draw the next points at pi. It shows undefined. At pi it will show undefined. So 0 to pi, the period is pi again. Tangent and cotangent has the period pi. Amplitude, no amplitude. Domain, it cotangent not exist or not defined when it is a integer multiples of pi. I will write in a cotangent function, no amplitude, period will be pi, domain all reals, but make sure x is not equals to n pi. Positive multiples of pi and negative multiples of pi not allowed in the cotangent, because at that cotangent is undefined. If I talk about the general graph, general function, y equals to a tan bx and y equals to a cot bx. In both cases, period will be pi over absolute b. Period on the both. Asymptote. Asymptote for y equals to a tan bx is, what values will give you asymptote? When x is pi over 2 absolute b. For asymptotes of y equals to a cotangent bx is x equals to pi over absolute b. Multiples of this. Multiples. Okay. You can write, here it's a odd multiples of this. Odd multiples, I can write is odd multiples of this. And there is an only multiple. Integer multiples. Okay. Alright. Look at this question. Graph 1 period then says describe the graph of G as a transformation for tanx. So what is the period here? The period will be pi over 3. I will draw the graph of tanx. The graph of tanx is, the period is a pi by 3, pi by 6 will be asymptote and negative pi by 6 will be the asymptotes now. At 0 it's a 0, at pi by 12 it's 2, at negative pi by 12 it's negative 2. Try to connect and form a curve. This is the graph. If you talk about the transformation, it is a vertical stretch by factor 2, horizontal shrink by factor 1 by 3. Done. You see in this graph, in this question it says graph for the 1 period, cotangent of 1 by 2x, describe the transformation and all. So what's the period? It's pi over absolute b. It is already positive, you no need to take absolute, so it's a half. So it's a 2 pi. The period is 2 pi here. The graph of cotangent is 0, 2 pi at pi 0, and it is undefined at 0 and undefined at 2 pi. This. Here is a graph of cotangent x. It is a pi. This is a pi by 2. At pi by 2 it is 1. At 3 pi by 2 it's negative 1. So what's the transformation? It is a horizontal stretch by factor 2. Because reciprocal of 1 by 2 is 2. Horizontal stretch by factor 2. This is the transformation. Okay. Now we are trying to graph the reciprocals for sine and cosine. Y equals to sine x, this is its graph. I have to graph for cosecant x. Cosecant x. That is a reciprocal of sine. Sine is a 0 at 0. And what is the reciprocal of 0? Undefined. So at 0, cosecant will be undefined. Where sine 0, cosecant will be undefined because that is the reciprocal. So at 0 it's undefined. At pi it's undefined. At 2 pi it is undefined. like this. Okay, here. This is also undefined at negative 5. How to graph other points? Sine at pi by 2 is 1. So reciprocal of 1 is also 1. So at pi by 2, cosecant is also 1. At 3 pi by 2, cosecant is negative. Problem is it can't go down. It cannot cross this point to this point because there is a asymptote, vertical asymptote. Graph never cross vertical asymptote. So you have a two choice. Either this function go up this side or this can go down. If it goes down, that means cosecant is a 0 at this point. Is it possible cosecant is 0? Cosecant x is 0. What is cosecant x? 1 over sine x. Is it possible 1 over sine x is 0? No. Because sine x never be undefined. This is always a finite value between -1 and 1. Even if it is 0, it give you undefined. It will never give you 0. 1 over sine x is never 0. So that means your cosec graph not going to cut x-axis. It will go upward. Instead of down, it will go up. So similarly, if it goes down, that means it cuts x-axis. But cosecant is not 0. So it has to go upside. Here, at 3 pi by 2, cosecant is negative 1. Cosecant is never 0, so it's not going to cut this line. So it instead of going up, it will go down here and here also. You can also draw the graph for this. It will go down and down here also. The black colored graph is for cosecant x. The blue is sin x, just for the reference I draw it. Similarly, look at the cosine. Cosine is 0 at pi by 2. So, at pi by 2, cosine is 0. So, reciprocal of 0 is undefined. So, secant is undefined here. Secant is undefined here. And here also. Because cos is 0 here. Okay. We have the graph. This blue is a y equals to cos x. I'm drawing the graph for the secant x. Y equals to secant x. Cos at 0 is 1. Reciprocal of 1 is 1. So cosecant is also 1. Is it possible secant x is 0? Secant x is 0 mean 1 over cos x is 0. And cos x is always a finite. 1 over finite is never give you 0. So it is not going to cut this. It's also go up. At pi it is negative 1. It also go down. At 2 pi it is 1. It go up. So black colored graph is for secant x. Blue is just for the reference for that. Okay. Period. Period of the function is 2 pi. Here the period is also 2 pi. No amplitude here. Asymptotes are there. Asymptotes. Asymptotes. What are the asymptotes here? Where sin x is 0. Sin x is 0 at n pi. So asymptotes are x equals to n pi. Because the reciprocal of 0 is undefined. So that are asymptotes. Here asymptotes x equals to odd multiples of pi by 2. 2n minus 1 times pi by 2. That's it. Odd multiples of pi by 2 give you asymptotes of secant x. In this function, gx is 2 secant x, we have to graph it. I draw the graph of cos x. I draw the graph of 2 cos x here. This is graph. So using this reference, I will draw the secant x. It will be up. Here it will go down. It says up to 1 period. So yeah, it's done. It's minus pi by 2 here, and this is 3 pi by 2. Minus pi by 2 to 3 pi by 2, we draw the 1 period for the graph of secant, 2 secant x. Okay, you can see what is the minimum value is achieving. Minimum value, it's a negative, it goes to negative infinity. Other points are at pi it gives you negative 2, at 0 it gives you positive 2, and the period is 2 pi again. Y equals to 2 secant x. Done. The period is 2 pi. Okay, next question. We have to graph dx equals to 1 by 2 cosecant of pi x. Can you tell me the transformation? In the last question, the transformation is vertical stretch by factor 2. Here, what is the transformation? Vertical shrink by factor 1 by 2 and horizontal shrink by factor 1 over 5. So let's start drawing. I am now drawing without reference of sin x. So 0. What will be the period here? We know that the period is 2 pi over absolute b. What is b? Pi. So absolute of pi is pi. So period is 2. 0 to 2. So here your graph will be this and this. This value is negative half. This value is positive half. Done. This is the graphing. We draw it. Okay. I hope you understand up to this. In this video, we done how to graph other trigonometry functions. Okay. We did some example also. We take other reference to draw the other graphs. I hope you understand. Thanks for watching.